Okay, so hi everyone. I'm Dan Brooks. I am strategy lead for digital manufacturing at the National Physical Laboratory. I've been with NPL for about 3 years now, and it's my responsibility to shape the direction of science and engineering research with all things digital manufacturing, industrialization, and digitalization, and all those things. Over the next 10 minutes or so, I'm going to look to explore why having confidence in the quality of data will help industry to make more informed decisions. Okay, so just a little bit about NPL to start with. So the National Physical Laboratory is the UK's National Measurement Institute. We're a world-leading centre of excellence in applied science and engineering. We are a private company, but a wholly owned subsidiary of the Department for Business, Energy and Industrial Strategy. So work very closely with both government and industry. We've got over 1,000 staff now, spanning a ridiculously wide range of disciplines and unique facilities. You know, all the way from life sciences and medical research, all the way to manufacturing, productivity, climate, and beyond. It really is a unique facility. We've got a few facilities up and down the country. Our HQ is in Teddington in West London. We've got places in Huddersfield and Glasgow and beyond, and a huge number of laboratories within those. As the UK's National Measurement Institute, you know, it's our responsibility to consistently push boundaries of measurement science, and we really do have practical experience in developing new technologies in that area and delivering that to industry. So manufacturing and data science are now incredibly close, and this is the area that I lead within NPL. They're close for obvious reasons now. And within manufacturing, it's NPL's role to provide confidence in the intelligent and effective use of trusted and traceable data. You know, developing measurement and data infrastructure that underpins the implementation of innovative digital technologies, which are coming out of universities, of other research institutes around the country now. And we do this again across many sectors, wide and varied, and the interoperability of this new technology across sectors, I think, is one of the reasons why there's so many benefits attached to it. Our approach is to develop real core capability through, firstly, theoretical research at a low technology readiness level, and then realize that impact through case studies and examples and collaborations with industry and other research organizations. So trust or confidence. So, okay, firstly, I'm sorry to be the one to use the buzzword of Industry 4, but bear with me. So let's consider for a minute what the underlying themes are in the industrial revolutions. So the first was reliant on people. So we needed to have trust in people. The second on process, the third on new technology, and the fourth on data. Now, trust is the key issue here. And trust in the data will be paramount if we're going to able to leverage the benefits of the new technologies coming through in this so-called fourth industrial revolution. Now, at each step here, we need to be thinking, how do I know that the data I'm using to make my decisions is true, is trustworthy? If the right data is not accurately captured, transmitted, processed, analyzed, then any decision-making process beyond that point, based on that data, is inherently flawed. So it stands to reason that if we can have trust and confidence that a new product or service or system or process meets the requirements and specifications it was designed to do, then that's going to inherently accelerate the development and adoption of new technology, which in turn will support UK productivity and competitiveness. So the way we look at the data lifecycle is through the information value chain. So I'll talk you through this. So on the top right is where you acquire data. So we're talking sensing, we're talking measurement, we're talking simulation, those kind of things. Bottom right is data curation. That's basically how you manage data, how you store it, how you transfer it, how you annotate it, and how you verify its quality. The bottom left being analysis. So how you process that data, how you analyze it, how you look at the uncertainty within that through various models and algorithms. And the top left is your decision making quadrant. So that's decisions and predictions and prognosis, and how you then link that back back to the real world. Now, a lot of the work you'll see within Industry 4.0 looks at going from the top right of this diagram to the top left. It acquires the data. It might plug a sensor into a machine, put that information up onto a dashboard, and take that information as true. Now, that's not always the case. And a lot of the work we're doing is in the southern hemisphere, if you like, of this information value chain. And given that there's an almost infinite amount of data can be gathered, and one of the most important questions to ask is, why are you gathering it? And what is it you want to know? So once that strategy is sorted, then it's all down to how effective your data acquisition is, how well you can trust it, and whether you can prove its validity if you need to when working with those decisions made. So in order to generate the systems and infrastructure that will give you this trust, it's important to understand the whole data framework and the quality of data within. So if we look at this as in a linear relationship, which obviously it isn't always, but all the way from collecting the data, so that's your sensor systems, as I mentioned, through connecting, so that's all of the connectivity, your data storage and transmission, through to comprehending and making decisions and fusing that data together and processing that. So it's important to understand the uncertainty and the quality of data that goes up and down this life cycle in this process, if you like. What I mean by uncertainty propagation is, if you think about it like an error within a manufacturing system and a tolerance stack, if you like, as you go through. So if operation 1 shows a small error, but it passes, then that component you think is great, it's fine. If that happens all the way through the system, then you're very quickly going to get a product that is out of specification. Now, that is obviously tracked with physical processes, but with data, it's often a lot more difficult to recognize and understand. So we do a lot of work in understanding the propagation of uncertainty through these complex systems to be able to identify those errors and those failure points. Now, a key framework to work on it, if ever this is being implemented, is using the FAIR principles. So, is your data findable? Is it in the right place? Could you get hold of it? Is it accessible? Has it been stored correctly? Is it interoperable? Can it speak to all the systems that you're asking it to? Your machines, your design packages, your ERP systems, and is it reproducible? Could you do exactly the same again and to the same quality? And that's a really good 4 questions to ask yourself when implementing these kind of data infrastructures. So now, one thing that sticks out to me always, and I'm a manufacturing engineer by trade, so I try and live in the real world. One thing that sticks out to me when talking about data and digitalization is that the real world isn't played out on a computer in a series of ones and zeros. So we must take into account the physical world too. So I'll give you an example. So the bottom right, the picture in the bottom right of this slide is a fixture certification process. Now, with a number of measurement instruments around it. Now, if you look at the amount of data points in this operation alone, if you don't trust the output of even one of these sensors, then you'll lose confidence in the whole system. Now, this is why in the real world, it's more likely to be about a relationship between the physical processes and measurements and the digital tools that give you that desired outcome. So it's really the merging of the two, I think, that's going to be really beneficial in the future. But by ensuring confidence in all of these data points, the data can then flow up and down the processes, up and down the supply chains, in and out of these physical processes, and still be used to make correct, often critical decisions, as well as improve the quality of these products and processes and systems that are being developed. So how do we make that all stick? So obviously, standards and the development of standards and standardized processes is a key area of NPL's business. Now, there are more than 20 billion connected devices in use around the world, which is hard to comprehend, really. But despite this, companies are only using a fraction of the data. And one of the problems is a lack of standardization between things like the communications between these systems. And I think digital standards are really vital to bridging this gap. So By establishing the required, from obviously I'm talking from a measurement perspective here, so by establishing the required test methodologies and providing capability for assessing trust in algorithms and software and the like, will ensure that new technologies such as artificial intelligence and machine learning can be used with absolute confidence. We think that this confidence and the standardization of this infrastructure will more than half the time it takes to generate an industry standard. And that will inherently help to drastically reduce the time and cost to market of new products that are essential for emerging focus areas, such as the development of new communications technologies and our drive towards net zero and a green future. So finally, what are NPL actually doing, and why is a measurement institute talking about specifically about data? Now, look, I understand that some of the core research work carried out within data science, it means very little to most people and most businesses. And as a manufacturing engineer, I include myself in that often. But it's important to understand that measurement occurs at every stage of the process, whether physical or digital, and it occurs all throughout that supply chain. So having confidence and understanding that system is really, really key. So we're working with research centres and industry UK-wide to develop sound measurement and data infrastructure that's really key to delivering smart manufacturing systems for the UK and beyond. Thank you very much.